750 million light-years away.
Its destruction produced a flare so powerful that, in ultraviolet light, it briefly outshone the entire galaxy surrounding it.
But the most disturbing clue was not the star's death. It was where the killer was hiding.
The flare appeared more than 30,000 light-years from the galaxy's center, where a supermassive black hole should not normally be found.
Astronomers may have caught one of the universe's rarest fugitives, a massive black hole wandering far from its expected home.
Was it thrown outward during a cosmic collision? Or is it the surviving heart of a galaxy that was almost completely destroyed? To answer that, we must reconstruct the final moments of the star and follow the trail left by an invisible object.
Because this single flash.
The story begins in a massive galaxy located approximately 750 million light-years away in the direction of Cetus.
Like most large galaxies, it should contain its greatest black hole deep inside its bright and densely populated center.
That arrangement is expected because gravity gradually draws the heaviest objects toward the bottom of a galaxy's gravitational well.
Yet the event astronomers discovered was nowhere near that center. It appeared far out in the galaxy's thin stellar halo.
For one unfortunate star traveling through that region, the darkness concealed a gravitational trap with no visible warning.
The black hole emitted no light of its own, so it remained effectively invisible until the star wandered dangerously close. Then the difference in gravity between the star's near and far sides became stronger than the star's ability to hold itself together.
The star was stretched, compressed, and ripped into streams of plasma through a process commonly called spaghettification.
Some of the wreckage escaped outward, but much of it remained gravitationally bound and began returning toward the black hole.
Colliding streams converted orbital energy into heat, creating a luminous disk of stellar remains around an otherwise dark object.
That disk reached extraordinary temperatures and released radiation across visible, ultraviolet, and X-ray wavelengths. For several months, the ultraviolet flare radiated with the combined brilliance of approximately 10 billion suns. A single dying star had transformed the hidden black hole into one of the brightest objects in its galaxy. This phenomenon has a name, a tidal disruption event. But this particular event immediately broke the usual pattern. Almost every tidal disruption event astronomers find appears in a galactic nucleus, exactly where supermassive black holes normally live. This one appeared over 30,000 light-years away, turning its location into the most important clue in the investigation.
For comparison, our solar system lies about 26,000 light-years from the black hole at the Milky Way's center.
This flare was displaced by an even greater distance, yet it still belonged to the same massive galactic system. The galaxy likely contains its normal central giant and a second, much lighter black hole hiding far away in the outskirts. Estimates place the wandering object near 1 million solar masses, while the galaxy's central black hole may be hundreds of times heavier. Without the captured star, the smaller black hole might have remained invisible for thousands, or perhaps tens of thousands of additional years.
But discovering the black hole created a deeper mystery. How does something this massive become stranded so far from a galactic center?
The first clue came from the Zwicky Transient Facility, which repeatedly photographs the changing sky from California's Palomar Observatory. Every night, the survey detects roughly 500,000 flashes, movements, and brightness changes that computers must rapidly classify. A specialized artificial intelligence system searched that flood for the light curve signature of stars being destroyed by black holes. In November 2025, it identified an unusual brightening now known as TDE 2025 ABCR. Its changing light resembled a tidal disruption event, but its remote position made that explanation seem almost impossible.
The algorithm had found a suspect. Now astronomers needed independent evidence that a black hole had actually destroyed the star.
Ground-based telescopes, including SOAR in Chile, separated the flare's light into a spectrum carrying fingerprints of the disrupted material. The spectral features, including evidence from hydrogen and helium, supported the conclusion that astronomers were witnessing a star being dismantled. NASA's Swift Observatory then examined wavelengths that ground-based telescopes cannot measure as effectively. Swift measured the flare at approximately 30,000 degrees Celsius, far hotter than the surface of our Sun. The source remained so ultraviolet bright that it temporarily overwhelmed the combined ultraviolet output of the surrounding galaxy. Combining the light curve, spectrum, temperature, and location allowed the team to eliminate competing explanations. A supernova destroys a star from within. Here, external gravity tore the star apart and forced its remains into orbit.
It was also not ordinary activity from the central black hole, because the radiation originated far beyond the nucleus.
Every clue pointed back to the same extraordinary answer. An unseen massive black hole had caught and destroyed a passing star.
The black hole itself was never photographed directly. Astronomers detected the violent consequences of its gravity.
Close to the event horizon, gravity bends light, warps trajectories, and prevents anything crossing that boundary from returning.
The brilliance came not from inside the black hole, but from superheated debris still outside the point of no return. The observed luminosity suggests the responsible black hole contains roughly 1 million times the mass of the Sun.
It is far heavier than black holes created by individual stars, yet lighter than the greatest monsters anchoring massive galaxies.
Once the stellar debris is consumed or dispersed, the wanderer will become nearly invisible again.
In a typical galaxy, a black hole may wait roughly 100,000 years between detectable tidal disruption events. Astronomers compensate for that rarity by monitoring millions of galaxies, finding only around 30 tidal disruption events in a typical year.
Its location is not a minor detail. It preserves evidence of a violent event in the galaxy's past.
Leading explanations both begin with galaxy mergers, when enormous stellar systems collide and combine over hundreds of millions of years.
During a merger, stars usually pass safely through empty space, but entire galactic structures are rearranged by gravity.
Each merging galaxy may bring its own central black hole, creating a crowded gravitational contest near the new nucleus. The first possibility requires 3 black holes interacting at once, a cosmic gravitational slingshot with an unpredictable outcome. Repeated close encounters can transfer energy to the lightest member, launching it toward the galaxy's distant outskirts. It might not escape the galaxy completely. Instead, it could spend billions of years following a huge orbit through the halo.
Only the rare capture of a star would expose the exiled black hole's position to distant observers.
But there is another possibility, and it may mean the black hole is not truly wandering alone.
The object may still occupy the center of a faint dwarf galaxy currently being consumed by the larger system.
Powerful tidal forces could remove nearly all of the dwarf galaxy's visible material, while leaving its central black hole behind. What appears to be an orphan might therefore be the last surviving nucleus of a galaxy, erased by a larger neighbor.
One explanation describes a black hole thrown from home. The other describes a home stripped until almost nothing remains.
Deeper observations may decide between them by revealing faint stars or debris still traveling with the black hole. Measurements of its surroundings may also show whether it is moving outward, orbiting the galaxy, or slowly sinking inward. If it remains bound, interactions with surrounding matter could eventually drag it closer to the galactic nucleus.
In the distant future, it might merge with the central black hole and release powerful gravitational waves.
That ending is only a possibility. What astronomers have actually observed is the star's destruction in its highly unusual location.
This black hole is not approaching Earth. It lies in another galaxy, hundreds of millions of light years away. The unsettling question is not whether this object threatens us, but whether our own galaxy contains similar invisible wanderers. The Milky Way grew partly by absorbing smaller galaxies, so theory predicts that some of their black holes could have survived.
Most would remain extraordinarily difficult to find, because a black hole without nearby fuel produces almost no detectable light. They might reveal themselves through gravitational lensing, captured gas, stellar motion, or another star's catastrophic final encounter.
That is why the artificial intelligence search used here may be as important as the individual black hole it uncovered. The newly operational Vera C. Rubin Observatory will repeatedly survey the sky with far greater depth and speed.
Its observations could uncover a much larger sample of tidal disruption events, including many occurring outside galactic centers.
NASA's Roman Space Telescope will extend that search deeper, detecting distant events across billions of years of cosmic history. Together, these observatories could transform isolated discoveries into the first reliable census of wandering massive black holes. That census would show how frequently galaxies lose black holes, inherit them from smaller neighbors, or carry several at once.
Wandering black holes are therefore more than cosmic curiosities. They preserve the history of how galaxies assembled.
The star that revealed TDE 2025 ABC.
Its destruction transformed invisible gravity into light bright enough to cross 750 million light-years.
That light entered our instruments, passed through an algorithm, and exposed a black hole that had escaped every previous survey.
One wanderer has been revealed.
If you want to follow the real discoveries reshaping our universe, subscribe to Sky Through Time and join our next investigation.
In the darkness between stars,